Hello everyone, I'm Mark Pinion, and today I will be exploring the concept of constant velocity motion and how Newton's second law can help us understand it better. First off, here's my tracker video. As you can see, I roll a bottle of vitamin water from right to left. Up in the top right here, we can see the x displacement on the y-axis versus time on the x-axis. As time progresses, the ball moves away from the origin in the negative x direction. This happens because of where I put my axes, which are centered on the bottle, and the fact that the bottle is moving from right to left across the screen. Now, using my data that I gathered from Tracker in these two columns, I created this plot. This plot shows what actually happened to my bottle as time progressed versus theoretically what would happen if there was actually constant velocity. The blue curve is what actually happened, and as you can see, it does not end up as far away from the origin as the orange line does. This is because friction and drag cause the bottle to decelerate. These forces being applied cause the velocity to slow down from its initial velocity of negative 1.003 meters per second to 0 eventually. Whereas the orange curve has a constant slope of negative 1.003. Here's my Python code. As you can see, the object moves from right to left from the origin at constant velocity. The graph has constant negative slope away from the origin, just like my plot. Here's some of my code blown up in a Word document. As you can see, the bottle is given mass, an initial position at the origin, and an initial velocity, which I calculated using data. The time step is how fast or at what intervals calculations are taken. Mine is 0.01 seconds. Now for the actual calculations, I chose to make my t 0.868 seconds for my loop because that is how much time passed in my tracker video from the time the bottle started moving to the time it stopped moving. The net force is assumed to be 0, 0, 0. Assuming this, we can conclude that the velocity does not change, or we have constant velocity. We can assume this because of Newton's second principle, which is illustrated right here. If the F net is 0, the mass of the bottle does not matter, and the delta T does not matter, because everything cancels because of this 0. So the final velocity of the bottle equals the initial velocity of the bottle. This simply moves the bottle as it applies the velocity to where the bottle was before. And this advances the clock so that the loop can do its work. One might ask whether or not the changes in y values affects the outcome of the experiment. The answer in our case, or in my case, is no. I'm assuming in my experiment that a change in the y direction is independent of a change in the velocity in the x direction. While this might not be the case in the real world due to things like surfaces with different frictions on different parts of the surface, since my bottle was on one carpet or rug, I'm assuming that the friction is constant throughout that rug and that a small movement in the y direction will not affect the x velocity. This movement in the y direction was caused by my initial push on the bottle to get it rolling. My push was not strictly horizontal, and as a result, the bottle experienced some movement in the y direction. Now, in relation to Newton's second principle, we can see that when there is 0 net force acting on an object, it does not matter what the mass is, and it does not matter how long the force is acting upon it. If there's 0 net force, there will be no acceleration, meaning constant velocity. And yeah.